So I now have the pleasure to introduce Henk Rogers, whom I just found out is Dutch. He may live on Hawaii, he speaks Dutch even, because he was born in the Netherlands and only later moved away from there. Henk Rogers has a passion for the environment. And having been to Hawaii, I would have a passion even more than I have in my own home country for the environment. And a healthy Earth, splendid idea. Next to his passion for the human colonization of the moon. And he will tell us how to do this, how to make way for space colonization, real and present. Present us now here, how you do this. Will it help us to get to Mars? Will it be helpful at all? I hope the answer is yes. And Henk, the floor is yours.
Testing. Hello. Hi. You know, the worst thing you can do is go before lunch. That's and even worse than that is you can actually delay lunch. So I apologize. I have a plane to catch, and the original schedule said 12:40, and the book said 2 o'clock. So there's a confusion. I live in Hawaii. And I had the opportunity to join the Polynesian Voyaging Society on part of their worldwide voyage, which sailed in a double-hulled canoe around the world using only celestial navigation, meaning no instruments. We had an emergency sat phone, but it was only for emergencies. So we basically looked at the stars, the sun, the moon, the wind, the waves, and the birds for guidance as to where we were going. So what were we doing? We were sort of recreating the technology that existed, which enabled the Polynesians to first find Hawaii. And where did they come from? You know, they came from somewhere like Tahiti or the Marquesas. How did they get there? You know, if we can trace it back, you can kind of trace it back to the area of Indonesia and the Philippines. And so they didn't start in Indonesia and sail to Hawaii the first time they ever sailed. It just didn't work that way. My theory, but there's no record of any of this, of course, is that they sailed to islands that they could see, and then they could, little by little, see a little bit further because of cloud formations, and then they started noticing birds that were going to other places, and they started connecting the dots, and they were able to sail to places that they couldn't see on the horizon. But this is only after they learn how to sail to the islands that are on the horizon. And so my suggestion again here is, how does this work? I mean, how does colonization work in the first place? So the Polynesians obviously must have, at some point in their history, had an exploratory mission to follow some set of birds across, I don't know, it's 2,000 miles of open ocean. To find out where the birds were going. And then obviously they made it back, because then there was a colonization effort after that, meaning they probably went back and got wives and pigs and things that would help them colonize. So here we are. It's now the 21st century, and we're trying to figure out how to do colonization. And the answer is, let's do the island on the horizon first, learn how to row back and forth, sail, learn how to sail, and go farther and farther until we figure out, yes, we've got this down, and then we go to Mars. So I have a plan. Actually, I started with science fiction. If you go back, I was just crazy about Star Trek and all that kind of good stuff. And so when it came time for me to find my missions in life, I found mission number 3 was to make a backup of life on Earth by going to other planets. The obvious planet that we need to go to make a backup is Mars, because it's the most Earth-like. We have got maybe an extra 40 or 50 minutes per day. It's got day and night. It looks like there used to be surface water. And it looks like, well, if we spend enough time and money, we can terraform Mars into another Earth. We're kind of terraforming Earth into something else, by the way, just so you know. I don't know, the aliens are here and they like it warmer. And so they've gotten us to heat up this planet. And so we understand how to warm up a planet. We're pretty good at it, and we can do the same thing on Mars. Just kidding. So here's my plan. First of all, I said to myself, I don't know enough about this stuff to really make a plan or to do anything. So the first thing I said, let's get all the experts, the experts that I could reach out to in one place, and let's talk about how to build a moon base. So we did. We had the MoonBase Summit. It'll be a year and a half now. The book that's over there is who came to the summit and what they had to say. We had lots of different sessions, and I came away with that buzzing with all kinds of information, more than I could handle. But I have a pretty crazy way of thinking about it, that we can actually do this by the end of the next decade. And I think that that's a good target for us to actually do something, to have a target by which, if you don't have a deadline, things just don't happen. We've been putzing around about going back to the moon for the last 50 years. We don't have a deadline. We need a deadline. I think the end of the next decade is a good deadline. I have a little Mars moon habitat where we practice being on the other planets, and that little flyer that's next to it is about that. We spent the last 5 years doing Mars missions. Thank you, NASA and University of Hawaii. They got together to figure out what's going to happen when we put people in a small space for a long time. We've had 5 missions, and I think Kim Binstead spoke to you guys yesterday, so you know all about that. Where do we go from here? First of all, we've pivoted from doing Mars missions, which are like 4 months, 8 months, 12 months, to moon missions, which are going to be 1-2 weeks. I pick 1-2 weeks because I'm looking forward to the day when there's going to be regular traffic between here and the moon, which is much easier than regular traffic between here and Mars. We can only do that once every 2 years, something like that. We can go anytime to the moon, and we can send resupply. So the Mars, or the Moon Mars High Seas, is made out of, it's a steel structure with a kind of a fancy plastic skin that resists UV. It's not sealed. It's 1,200 square feet. And it's built, there's no way for us to make food in there. It's just not big enough. 6 people stay in 1,200 square feet. Basically, we give them all the food that they're ever going to eat during the entire mission at the beginning of the mission. All they do is add water. So we have freeze-dried food. We have lots of powdered stuff. Anyway, all long shelf life stuff. And that, in my understanding of the way colonies worked in history, is that there hasn't been a colony that survived that wasn't self-sufficient. If you wait for your home country to keep on sending you food, then it's not really a colony. It's not working. It's maybe a research station or something, but it's not a colony. The colony has to be able to grow its own food. So I'm working, trying to get 1,000 acres on the Big Island of Hawaii out of the military. They have 140,000 acres, which is way too much. They use part of it as bombing practice. They have little fake villages that they capture, and they do all of that. They even send planes and drop bombs, and they do artillery. It's the only place in the Pacific where they can practice. So they're not going to give up the base. But I'm asking for 1,000, which is even not even 1%. So what's the big deal? Hopefully NASA will help me, or Bridenstine will help me, or somebody will help me push them over the edge, because they don't really care. And what I want to do there is build a campus, the International Lunar Research and Development Park, where all space agencies, all space companies, all space institutions can work together and build moon-based prototypes. My first moon-based prototype, I'm thinking should be, I think it should be like 20 people. I have a guy, Rodrigo Romo, who's working for me in Pisces, and he spent 8 months in Biosphere 2. And Biosphere 2, 8 people spent 8 months all they did was grow food, and they were always hungry. So that is not a good formula for success of a colony or a Moon or a Mars mission. So what I want to do is do. I'm originally from Holland. I became the honorary consul of the Kingdom of the Netherlands to Hawaii, Guam, and the Northern Marianas, wherever the hell they are. And Holland turns out to be the second largest exporter of food product, or of ag product in the world, $100 billion export business in a space the size of Hawaii. It's like, how the hell do they do that? And the answer is they do it indoors, and they don't do it outdoors. And they don't do it in the ground, they do it on concrete. So it's all hydroponic. I think that's the way we need to grow food on the Moon and Mars. We can't like try to duplicate a forest and try to grow food in the forest. We actually have to get really clever about it. And that's something that we have to study. I think people are studying this, by the way. So the next MoonBase, I think 20 people, that's just a guess. Somebody's going to have to correct me on this because I'm not an expert in any of this. And then a big space to grow that food. Maybe 2 or 3 of them will be growing food, and the rest of them can do what we expect people to do on the Moon and Mars. So the first one, I'm expecting it to be sort of metal and plastic. The second one, once we figure out, whether we got the size right at the cheap structure, I want to make the second one out of concrete and pressurize it. I want to pressurize it to the same difference of the atmosphere inside and outside as the Moon. Moon, let's say it's 1 atmosphere in the base, it's 0 atmosphere on the outside. That difference, we can pressurize the base so that the inside and the outside has the same difference. So if you go outside, you're going to have to go through an airlock, or something bad is going to happen to you. So I think we can simulate the Moon base, including everything that we grow, out of concrete. That's the next phase. In the meantime, I'm expecting us to develop robots that can actually dig into the ground and that can 3D print that moon base out of the in-situ resources. So we've been practicing by sintering Hawaiian regolith, which is the rock in Hawaii. Why rock in Hawaii is so similar to the Moon and Mars is because it's oceanic crust. The Moon and Mars is all oceanic crust. So if you're going to build something out of in-situ resources on this planet, pick Iceland, Galapagos, or someplace else that's made out of oceanic crust. We even have lava tubes and skylights for those of us out there who believe that we're actually going to try to build stuff inside lava tubes. By the way, a lava tube, the way we know that they're there is it's called a skylight. I've been down skylights. There's a bunch of them around our high seas habitat. And it is a dangerous climb down. And especially more difficult if you're wearing a suit, which we make everybody wear. Every EVA is wearing a suit. It's just a hard thing to do. And at the bottom, you've got these big boulders, so anything you roll down gets stuck in the boulders, because that's the collapsed roof of the skylight. So I would much rather have a fleet of robots go to the moon, dig holes just like termites do, and then create spaces, and then harden the spaces using 3D printing. And all we have to do is add doors, meaning so that we can get in and out of the pressurized, create the atmosphere and pressurize it. So whatever we do in Hawaii, or whatever we do on the moon, I think it's directly applicable to what we do on Mars. I think it should be underground, because that protects us against radiation. We can send a fleet of robots. They can get on with building the moon base before we ever go there. And then we have those spaces that we've built to our specifications, not to the lava tube specifications. And we can, engineer them. Rather than hope that we find one that fits the bill. I don't want to take too much time talking. I want to make sure that we get plenty of questions. I'm not an expert in any of this, but I do have a vision, and I do plan to build a moon base on the moon with the help of all of you by the end of the next decade. Did I forget something?
I know you guys are quite ready. Anybody have a question for Henk before he goes and hops on a plane? I see Robert coming down.
When you start thinking about colonization, I don't know if we can get away with just vegetarian diets. A lot of people always focus on the plant growth. Have you given any thought to animal growth or seafood or any other alternatives to vegetables? Well, to plants, rather.
Right. So to figure this out, by the way, I stopped eating meat and fish last year, and I just started eating it again. But I mean, I got away with a year without eating meat or fish. So we're perfectly capable of having a diet. When you think of a cow got to be a cow because it ate grass. So all the stuff that you need is actually contained in the vegetable matter. It's really hard to keep fish alive or anything alive. I would say probably chicken is the easiest way, but I don't know how chicken's going to react to anything except Earth gravity. So we may have to like put weights on their feet or something and make them think they're on Earth, or who knows. But chicken I can see, because our chickens, they eat whatever our scraps are and turn it into eggs. How awesome is that? Eggs are great. It's just have to give them the eggshells back to them so they have calcium, and they eat our kitchen scraps. So.
Well, in response to that specifically, we had a lovely breakout session yesterday about agriculture and food that we could be having on the moon or Mars, including cell-based, growing fish just from cell cultures. So I highly recommend checking that out from Finless Fish. But my question is, right now you have this analog base on Earth, and how are you using that in order to invite people outside of the space industry in order to have that kind of experience and get inspired? Who are you inviting whenever you aren't doing research?
So we all have to quote unquote do research. That's the permit that we have from the Department of Land and Natural Resources. So we did think about, like, what about doing some, lunar Airbnb? And in fact, we did talk to Airbnb, but the thing is, it's like going up to the ISS. Not really that interested in having people go up there and just for vacation. I would like to inspire them, and I do take people up there, and I myself go up for 48-hour missions. If I can get people that are interested or somehow motivated, whatever, then I'll take them up for a 48-hour missions, take them on EVAs, by the way, which you have to wear sort of a spacesuit. So I've taken a lot of people who weren't specifically interested in Mars or the moon to spend time there so they can understand it. And the other reason for going from like 8 months missions to 1 week, 2 weeks is that we can get students, give students the opportunity to spend time on the moon or Mars. But when they're in a mission, they're going to continue to carry out experiments that we start that are multi-mission experiments, whether it be geology, whether it have to do with food growth or whatever it is. The difference between the Mars missions, where they were comparing different psychologies of different groups, and therefore they couldn't change the conditions of the test, so we couldn't change the habitat, basically. That's out the door now. We want to get feedback from every crew that stays with us and find out how can we improve it, and we want to iterate and iterate so that when we get to the point where we're actually building a big one that includes food generation, that we have already improved it to the point where we know something about something.
Great,
And last question over there.
So the idea of an international moon-based campus is really phenomenal, and I want to know what is the next step and what this community can do to help.
Okay, so I have a weekly call with a group of people at NASA Ames. It used to be called the NASA Lunar University, and now it's the I forget, they've changed the name several times. But it is a concerted effort by myself, a couple of people in Hawaii, and the NASA Ames people. And the idea there is to have a campus in Silicon Valley at NASA Ames, and another campus where you can actually have regolith outside your door. 1,000 acres, I would think that there's going to be a bunch of buildings where people send people to do research, where we internationally cooperate on things like what percentage of, what should the pressure be? Should we be using metric? Should we, all these things that seem fairly obvious to most of the world don't necessarily seem so obvious in this country. But they should be obvious on the moon. We should standardize. And the idea of the MoonBase would be that anybody who has an idea about how a MoonBase should be built can just connect their section of the MoonBase to an airlock. And therefore, you can have many different ideas. You can have an inflatable, you can have something at the surface that's buried, or you can have something that's buried underground or dug out from underground in the first place. So I want to make sure that that what we do there is inclusive. My model is like international airport. Once you get there, we don't care where you came from. We're just there to survive and live on. We don't need you to tell us what country you're from, because that is not the important thing. We're all humans, and we're trying to survive in a very harsh environment, and we need everybody's help to do this. So it's going to be the same on the moon. We'll practice, and then we'll get to Mars once we know what we're doing.
Give Henk another big round of applause.